Okay, on problem number 4, it says for each positive integer n, so n's an integer again, they have a parabola, it's quadratic, that intersects the x-axis at point an and bn. What is the value? And this is tough because it's the sum. And the sum starts with a1, b1 plus a2, b2 up to a 2018, b 2018. Well, I gotta think about that. So let's put this down. And this is problem number 4. Let's write this down. So number 4, you're given a parabola y equals, and that's going to be n squared plus n x squared minus 2n plus 1 x plus 1. And again, they say it's a positive integer, so I know n is a positive integer. Right, so what do I know about this thing? I know it's a parabola that opens upward like this over here. I know that much. And it goes on to say about intersects the x-axis point a and b n. So I got to find out what the zeros are. So I'm going to set y to be 0, and you get this over here. Now, I'm not saying it's not factorable, but I'm looking at this thing, and I'm just going to just use the quadratic formula. And what are you going to get? X equals, let's see, twice the coefficient of the square term goes on bottom. That's n squared plus n. The opposite of the coefficient of the linear term, so it's going to be 2n plus 1, plus or minus. This is always the tough part for me, the root. And it's going to be the linear term's coefficient squared. So it's going to be 2n plus 1 squared minus 4 times the coefficient on the quadratic term. So it's going to be n squared plus n times a constant, which is just 1. Let's simplify this. Hopefully it's going to be nice. And what do you get there? You get 2. You get an n. I'm going to factor the bottom, by the way. Get n plus 1. On top, you get 2n plus 1 plus or minus. I got to figure out the radicand, by the way. And you get 4n squared plus 4n plus 1 minus 4n squared minus 4n. Well, these disappear, and that's good. You just get 1 over here. So it's getting a little bit easier to look at. It could probably factor the original expression, by the way. But you're going to get 2n plus 1 plus or minus 1 over 2n n plus 1. So it's going to be 2 different answers, by the way. It's going to give me 2n plus 2 over 2n n plus 1. I'll simplify that later. And it's going to give me 2n, well, let's see, it's going to be 1 minus 1, which is 0, over 2n n plus 1. So this answer is pretty simple, and it's a positive integer. The n cancels. You lift up with 1 over n plus 1. Let's see what this one gives us. It's going to be 2 n plus 1, 2n n plus 1. And this cancels. Again, n's a positive integer. And this cancels, and you get 1 over n. All right? So I got my solution set. And the solution set for the intercepts, and again, n is a positive integer. You know, if I looked at a1, and the roots are going to be a1, b1. So I'm going to call this thing a1. I'm going to call this b1. So a1 times b1 plus a2 times b2. I'll write these down in a moment, by the way. And it goes yada, yada, yada. It eventually stops at 2018. Gee, I got to write that down, don't I? So what's a1? It's 1 over 1. What's b1? It's 1 over 2. Let's put the a2 down now. What do you get there? 1 over, that's going to be 2, and then 1 over 3. What's next one going to be? 1 over 3 times 1 over 4. I'm tired already. I'm going to go to the end, and the end's going to look like this. It's going to look like 1 over 2018 times 1 over 2019. All right? So I'm kind of looking at that. I know it's a sum. And I know something about the sum. I'm going to write it down for you. It's a summation problem. And I'm going to say it looks like the top is always 1, but the bottom looks like n, and then n plus 1. And this starts at 1, and it goes up to 2018. All right? Let's see if that's true. I get 1, 2, 3, up to 2018. The second factor would be 2, 3, 4, up to 2019. The next thing I would do is I'd do partial fraction decomposition, because this looks like a telescoping sum to me. And let's write that down. But to do that, I want to go through it with you first. So 1 over n plus 1 is equal to a over n plus b over n plus 1. Multiply both sides by the LCD. You can get 1, a, n plus 1, plus b, n. I'd pick an easy n, by the way, because I want to figure out what a and b are. So I'm going to pick n to be 0. And what would you get there? You would get 1 equals a. So a is 1. Let's try to do the b now. I'm going to pick n to be minus 1. You can get 1. The first term disappears because minus 1 plus 1 is 0, so you just get minus b. So what's b going to be? Minus 1. So write this over here. Then write this down, 1 over n minus 1 over n plus 1. I'm going to erase the side work, by the way, and the reason for that is that the partial fractions, some people actually do it in their head. I can't do it in my head, by the way. I have to write it down. But I got the partial fraction decomposition completed. So what I'm going to do is use that to see the telescoping part of this thing over here. So let's write this down. You know, if I just put the 1 in, you get 1 over 1 minus 1 over 2. The next term would be 1 over 2 minus 1 over 3. The next one would be 1 over 3 minus 1 over 4. I think you get the idea. And then you go yada, yada, yada. Let me put the next one down for you. 1/4 minus 1/5. And go towards the end. What's the end going to be? Well, let's do that. It's 1 over 2018 minus 1 over 2019. Now, granted, there's something prior to this over here. It's 1 over 2017 minus 1 over 2018. Now, what do I notice about this over here? It's a collapsing sum. These things are just disappearing. And this will disappear with that. This will disappear with that. And I'm left off with something pretty simple. I'm left with 1 over 1 minus 1 over 2019. Question is, what's that answer going to be? I got to add it together now. Calm down to 2019. And you get 2019 minus 1, which is 2018 over 2019. And we're done. Thank you.